चलो ठीक है. अच्छा, न्यू टॉपिक जो है ना, that is the one that we're going to start is reaction kinetics. और अच्छा, इसमें ये कि you did some reaction kinetics in ES. ये उसमें ज्यादा नहीं किया था. You did very little. The rate of reaction basically, ठीक है. And in ES you kind of didn't really you didn't really do a lot. तो पहले तो ना we'll just do the basics. कि वो basics में क्या क्या था. The basics में we had I mean speed of reaction के अंदर ना they are, I mean you talk about collisions. ठीक है. और collisions में क्या होता है कि all reactions they happen because particles are colliding with each other. So let's say मेरे पास I've got a bunch of particles and I've got a bunch of other particles. So the reaction will happen if the two particles eventually meet and they collide. और फिर उन्हें जो भी करना है, whether they want to lose electrons, gain electrons, break bonds, form new bonds, ठीक है, all of that would be happening. But it has to happen if they collide. Okay, and collisions are going to be described in two ways. So when you talk about collisions, though, there are two ways in which you're going to describe all these collisions. The first one is the frequency of collisions. That's a frequency of collisions to it. That's how many collisions are basically taking place. Okay, and the second is इसको बल्कि लिख लेते हैं. That's the number of collisions per unit time. And the second one, just second, and the second one is that is the effectiveness of collisions. So are they colliding effectively or not? You might be collisions. I mean, you might have 1,000 collisions per second, but maybe none of them are effective or successful. So it's gonna different the different ways of you can say proportion of successful collisions. इस term को ना it's a proportion of successful collisions. You can also call this the percentage of molecules having the activation energy. So the percentage of particles or the proportion of particles having activation energy, ठीक that's the minimum amount of energy that's required for a successful collision to happen. ठीक so remember, all collisions are going to be described in these two terms: frequency of collisions and the effectiveness of collisions. So very quickly, ठीक वो five factors are which determine. Remember, ये सारा भी पुराना ही है. ठीक there are five factors that determine the rate of reaction. The first one, that is temperature. So what happens when you increase temperature, your particles become, so नीचे लिखते हैं, if you increase temperature, so what happens, particles they gain kinetic energy. Okay, they become more energetic. So both frequency, because they're traveling faster, so both frequency and effectiveness of collisions increases. एक तो वो they're traveling faster, so they're going to collide more often. Plus, they're going to be colliding with a lot more force, so there's a lot higher chance of the reaction happening. So increased temperature particles gain a kinetic energy, so both frequency and effectiveness of collisions. Increase, ठीक है. अब इसको मतलब further इसमें एक चीज याद रख लो कि every 10 degrees centigrade the frequency of collisions it almost doubles. खैर वो इतना important चीज नहीं है. We'll just going to jump to the next one, which is concentration. And so now concentration is that it only applies to gases or solutions. So concentration is basically what it's kind of the spacing between particles. So if you have a liquid, you could have a very concentrated solution, or you could have a dilute solution. तो आगे जाके डिटेल में ना जो चैप्टर होगा, this will talk a lot about this specific. It will talk a lot about this specific thing. So concentration is about spacing of the particles. So the particles could be very tightly spaced together in a solution or in gaseous state, or they might be very far apart from each other. Now, what happens with concentration is that it does not, I mean, effectiveness of the collisions does not change with concentration. The only thing that changes is if you increase concentration, acha wording important hai, if you increase concentration. So what happens? Particles they become closer to each other. Yes, gonna technical terms, you got more particles per unit volume. So you have more particles per unit volume. ये जो concentration था इसका moles का formula क्या था? That was the number of particles moles over volume. ठीक है? This was the formula. So remember, only frequency of collisions increases because there are particles more tightly packed. So only frequency of collisions increase. The particles are colliding with the same force. Okay, that does not change. This way, it's only frequency. Okay, I'm just going to underline that. पिछले वाले में it was frequency and it was also effectiveness. ठीक है. So ये clear हाला Umar, middle is this clear?
Yes, sir.
That's the third one. क्या था third? Third is pressure. So now when it comes to pressure, pressure is only for gases, it's only applicable for gases. So obviously when you increase pressure, what are you actually doing when you increase pressure? Gas का जो volume है ना, the volume of the gas decreases. So for example, if I have this, so let's say I have this piston. So I have this piston. So ये मेरे पास अब piston है, ठीक है? And if I'm going to increase pressure on a gas, so the piston would be pushed downwards. So what happens is when you increase pressure on a gas, you can remember gases के अलावा it doesn't really count. So when you increase pressure on a gas, its volume decreases. And then you have more particles per unit volume. The particles are more tightly packed, so they're going to collide more often with each other. So you have more particles per unit volume. Hence, more more frequent collisions occur. Okay? Or so again, you get more frequent collisions. इधर मैं ऐड कर लेता हूँ disclaimer कि percentage of or the proportion of effective collisions remains the same. अच्छा, anyway, number four क्या कि surface area quickly कर लेते हैं. Surface area is smaller particles have more surface area. वो आपको पता है कि it's when it's powdered. So powdered में what's going to happen is कि uh, more frequent collisions would happen. Okay, so if you have smaller particle size, you therefore have more frequent collisions. बस इसमें और कुछ ऐड नहीं करना, ठीक है? So these are your four factors. Wording you have to, अच्छा इसमें भी last one also, frequent collisions. ठीक है? Proportion of effective collisions would remain exactly the same. सिर्फ temperature में the effectiveness would also increase. ठीक है? अच्छा, fifth factor जो last factor, that is a catalyst. तो उसकी ना वर्किंग के ऊपर डिटेल के अंदर डिस्कस कर लेते हैं. What does a catalyst do? Because this is going to be linked with our last chapter as well. So let's do this in detail. So what does a catalyst do? It's a catalyst क्या कहता है? Lowers first thing. Lowers activation energy, yeah, which is the minimum energy that's required for a collision to be successful. As a lowers activation energy, and how does it lower the activation energy? It provides an alternate path for the reactions, for the reaction, which is easier. So you get what you get is more effective, hence proportional effective collisions increases. The frequency remains exactly the same. It's only that the same collisions are now they're now being a lot more successful. So hence you get a higher proportion, yeah, simple proportion of that's a hence proportion of collisions increase. So that is what a catalyst does. क्या और क्या होता है? मतलब बस proportion of effective collisions and the frequency of collisions remains exactly the same. So now the next thing that we're going to do is catalyst. Remember, sticking to catalyst. We'll just talk about. If you're going to discuss कर लें, we'll talk about first one. कौन सा heterogeneous catalyst? Let's do heterogeneous catalyst first. Then एक example which is very important. You need to know these examples exactly. अच्छा, heterogeneous catalyst is when the catalyst and the reactants don't have the same state. They are not in the same phase. So So catalysts and reactants are not in the same phase. Now, so an example is you've got N2 and H2 reacting, and when they react, they produce ammonia. Okay, so they produce two molecules of ammonia. Or the iron is a catalyst, which is a solid. Yeah, iron is a catalyst. Now, what iron does is that there are there are two stages. So firstly, why is the reaction so slow? The N triple bond N is very strong and non-polar as well. So it doesn't really attract anything. Hence, very few collisions are effective. So you don't get a lot of successful collisions because it's hence very few. क्या लिख रहा हूँ? एक से इसको सही कर देते हैं। सही लिखना है कि hence very few effective collisions. अच्छा अब so there are very few effective collisions. So how does the catalyst work? The catalyst works in two stages. One is adsorption. That the catalyst is going to provide an alternate path, which is that the catalyst would end up would form weak bonds with reactant molecules. So as an example, if I have N triple bond N and I have H2 molecules, and here is the iron catalyst. Okay, so this is the iron catalyst. Now, what the catalyst would do is that the catalyst has or your transition metals की एक property है, which we'll talk about in just a few moments. That transition metals have this property, which is transition metals have this a property that they don't like to really lose electrons. Transition metals are very unreactive, and because the higher number of protons that transition metals have, they have this weak attraction for electrons as well. So they don't attract electrons very strongly, but they do attract electrons somewhat. Okay. So adsorption is that the catalyst, I mean the triple bond over there, what would happen to the triple bond is that it will eventually get attracted. Its electrons are going to get attracted to the iron catalyst. So next stage में क्या होगा? Next stage में the triple bond electrons, nitrogen would actually stop sharing electrons with each other. Instead, they will eventually end up forming weak bonds with the catalyst itself. OHs, instead of sharing electrons with each other, when they collide with the catalyst, they'll start sharing electrons. Not sharing electrons, I mean, electrons would slightly be attracted to iron. So these molecules over here were coming in and they were basically bouncing off the catalyst. So they have some kinetic energy, and when they come very close to the catalyst, their electrons, which were over here, they got attracted to the catalyst and they ended up getting stretched or they ended up forming weak bonds with the catalyst itself. Of the last stage is that's called deadsorption. The next stage is deadsorption. Those bonds are going to break. Okay, so the next stage is deadsorption. So when these molecules with their kinetic energy, when they're going to fly off, the same bonds that were formed, they would eventually break. and the atoms will then be flying away. But as a result, their previous bonds have been broken, and now new bonds can be formed. So this end would be flying away. You get this one. So all these particles they would eventually end up flying away, and as a result, they can now form new bonds. So deadsorption, I'm just going to write the definition, which is that the weak bonds between so the weak bonds the weak bonds between reactant and catalyst break, and now new bonds can be formed. New bonds can now be because that's the whole process. ये clear है सारा को बिनल उमर हाला is this clear?
Yes, sir.
Yes.
अच्छा तो adsorption deadsorption two things. इसके अंदर I'm just going to talk about iron a little bit. ठीक है. Why are transition metals such good catalysts? They have this property के अगर मैं iron वाले group पे देखूँ ना, I think it's got potassium. I mean the same period, right? You've got potassium with 19 protons. You've got iron somewhere in the middle, which is 26 protons. And then you've got bromine at the extreme end, same group, 35 protons, right? So you've got a metal, a very reactive metal. Transition metals appear somewhere in the middle. And then you have this non-metal. Now, the tendency when you go across the periodic table, that is that atoms they tend to gain electrons, right? Because you got more protons. Okay, so as you move to the right, electronegativity increases, right? You got more protons, which means you gain electrons, which means you are more electronegative. So the one that's on the left side, that is always losing electrons. It doesn't, इसके जो outer electrons है, it's not very strongly attracted to those electrons because it's got 19 protons, right? But the one that's got 35 protons is a very strong attraction for electrons. So it's always the one that's it always gains electrons. अच्छा, transition metals जो बीच में ना middle में, they are kind of somewhere in the middle. They've got a higher number of protons, but not really high enough. They don't have 35 protons, but they've got 26. At least they have higher protons compared to potassium. So with transition metals, the thing is, they can actually weakly lose electrons. Okay, they can weakly, because you've got a higher number of protons. So if you have a higher number of protons, you're obviously more attracted to electrons. So it's harder for transition metals. I said it's harder for transition metals to actually lose electrons. So it's very difficult for them to lose electrons, which is why iron is not very reactive. You make a chair out of iron because you know it's not going to react. It might lose electrons very slowly. It might rust very slowly, but that's going to be very slowly. There are other transition metals which are even better catalysts that are very unreactive, like platinum or gold. They never lose electrons. They never form ions. So the thing is, it has a very weak tendency to lose electrons. And at the same time, it also has a weak tendency to actually gain those electrons back again. I mean, they can actually weakly gain electrons as well. So they can kind of do both things. They can lose electrons. and they can do both things weakly. But अगर यहाँ पे ना if I had bromine over here, right? Bromine can't act as a catalyst because bromine would pull the electrons very strongly. It will never let go of them. Okay. If I had sodium over here, sodium, agar iron ki jagah if I had sodium, sodium would never really attract electrons. That's never going to happen. Sodium is always losing electrons. So it's a good thing that transition metals can weakly attract electrons, and they can also let go of those electrons. I mean, they're not really strongly attracted to electrons as well. So what's so that is one property of transition metals that makes them very good catalysts. For example, if you have iron, well, it can lose electrons and it can form iron 2 plus and might let go of 2 electrons, but it can gain the electron back and form iron back again as well. Okay, so 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 that is a good property to have, which is why they can sort of be intermediates. Like if the reaction is not happening in one step, you can add a catalyst. The catalyst can gain electrons from somebody, and it can also lose electrons at the same time. Okay. So you throw idea clear. Is this clear? Okay, why are transition metals good catalyst? Okay, they can gain electrons and they can lose electrons as well. Is that clear?
Yes.
हाला clear हो clear है?
Yes, sir.
अच्छा अब ये कि ठीक है. So we call example, and that is for a homogeneous catalyst, and that's related to the previous chapter that we did. Remember, higher potential gains electrons, lower potential loses electrons. ठीक है? अच्छा, homogeneous catalyst. So the reactants and the catalysts, and catalysts have same phase or the same state. So that's what a homogeneous catalyst is. I mean, कोई भी reaction का example, if it has the same state, it's a homogeneous catalyst. So we're going to do one example, which is, I mean, there are two electrode reactions. So there are two electrode reactions. This E naught is, I think it's 2.01 volts. And there's an iodine reaction. इसका जो E naught है ना, that I think is 0.54 volts. Anyway, so you want to figure out what the reaction is. So the reaction is simple. This is the higher potential, it gains electrons. And this one is the lower potential, it would lose electrons. So higher would gain. And the lower one would lose electrons. Okay. So you know what the reaction is, and you can create an overall reaction by adding the two reactions. The electrons gained and lost are already equal to electrons being gained and two electrons being lost as well. I'm going to add up the reactants. Okay. So the first equation reactant is S2O82 minus. The second equation reactant is 2I minus 1, and the product is 2SO4 2 minus, and the other product is iodine. Okay, so this is the reaction that's going to happen. We can calculate the feasibility of the reaction by measuring the E naught cell, which is the reduction potential, minus the oxidation potential. So it's 2.01 minus 0.54. You're going to get 1.47 volts, which is fairly positive. So that means it's a very feasible reaction, right? So it's a very feasible reaction, and this reaction is very likely to happen. क्योंकि S28 को जो है वो इलेक्ट्रॉन गेन करने का शौक है, it's got a very high potential, it will gain electrons. I has a lower potential, so it wants to lose electrons, and we already know कि I is a very good reducing agent. We studied group 70 and we knew कि I minus 1 really likes to lose electrons. It's one of the best reducing agents, right? तो reaction तो होना चाहिए, and it's a very feasible reaction, except for one huge problem. The reaction never actually happens. ठीक है? Because the reaction has an extremely high activation energy. So in reality, in theory, it should happen, but in reality, no reaction happens. It's got a very high activation. What's the reason for the high activation energy? कि अगर आप इसको गौर से देखो ना कि although theoretically it should happen, but there's a very simple reason why the reaction is never going to happen, and that is that both of these ions are negatively charged. So अगर वो भी negative है and the other one is also negative, so the thing is they're never going to meet. It is very hard for two negative ions to actually undergo a collision, but they're just going to avoid each other. Okay, it would require a lot of energy, a lot of effort to bring the two negative ions together. But बहुत ज़्यादा, I mean, you need a very high kinetic energy so that the two particles could in fact collide with each other. So the thing is, कि very high activation energy क्यों है? Both ions are negatively charged, and they repel each other. ठीक है, they repel each other, so they never undergo a collision. ठीक है. अच्छा, यहाँ तक is this clear कि why this reaction has a very high activation energy? Is that clear? Middle clear, hala, Mava, Uber, is this clear?
Yes, sir.
Yes.
So अब यहाँ पे ना बीच में, what you're going to do is you're going to add a catalyst. ठीक है, in equations को ना, I'm going to pick these equations, and I've now realized that these two are never going to react with each other. ठीक है, copy करते हैं, copy. As I've realized that these two are they're never actually meeting each other. So what I'm going to do is I'm going to separate the two reactions because it's pointless to even think about them reacting with each other. So what we're going to do is we're going to add a catalyst in the middle, which is iron ions. It's iron 3 plus and iron 2 plus ions are added. So their E naught is exactly between the two. Here, their E naught is exactly in the middle. Now, when I add this third species in the mix, so what will happen is, we're going to look at the iron ions are going to go and they're going to react with the ऊपर वाले के साथ भी करेगा, नीचे वाले के साथ भी, ठीक है? So if it goes and reacts with the top one, right? So who gains electrons? S28 would gain electron, and iron ions would be the one that would lose electrons because this is the higher potential and this is the lower potential. So we can create a reaction for double color so that the electrons gain and loss are equal. And I'm going to add up the reactants. The reactants are S2A2 minus, and the other reactant is 2Fe2 plus. Then the product is in the first one it's 2SO4 2 minus, and the second one the product is 2Fe3 plus. And so we get this reaction. अच्छा, the same iron ions would also go, and the same iron ions would also react with iodine as well. So when they react with iodine, what happens in that case? Okay, iodine is the lower potential, so that is the one that's going to lose electrons, and iron ions relative to iodine are the higher potential, so they're the ones that would gain electrons. तो इसमें क्या होगा कि it's I minus 1 that would react, and iron 3 plus would turn into iron 2 plus. अच्छा, so अभी फिलहाल यही कि iron ions were added, and these iron ions ended up reacting with S28, and they also ended up reacting with I minus 1. S28 के साथ, that was the higher potential that gained electron, and iron ions were the ones that lost electrons. The same iron ions, when it comes to iodine, iodine is the lower potential, so that lost electrons, and iron ions are the ones that gain electrons. So you're getting two separate reactions. देखिए अगर, if you look at those two reactions, what you'll notice is you're getting both of your products. और ये वाला product देख लो, you're getting that. और इधर कौन सा product है? Iodine. You're getting the other product as well, but in two separate steps. And what is happening to the iron ions? वो Fe2 plus था, convert किसमें हुआ? Fe3 plus में. The same Fe3 plus then got converted back into Fe2 plus. So the catalyst, it eventually remained unchanged, but you got both of your products. ठीक है, दोनों products जो है ना आपको, in two separate steps you've gotten both of your products. ठीक है, Minal, Umar, is this clear?
Yes, sir.
तो ठीक है, ये रिव्यू भी कर लेंगे अगली क्लास में इसका, मैं भेज भी देता हूँ इनके नोट्स, तो नेक्स्ट क्लास में कंटिन्यू करते हैं, ठीक है।